At 3:45 on August 12, 1953, sparks from a cutting torch touched flammable liquid inside a conveyor pan at General Motors Hydra-Matic factory in Livonia, Michigan. Within 20 minutes, fire had raced through a building larger than 30 football fields. Cadillac, Oldsmobile, and Pontiac suddenly lost their only source of automatic transmissions. So did Lincoln, Nash, Hudson, and Kaiser. The surprise is not simply that the factory burned. It is that one component plant could stop rival car companies across Detroit. How had a $57 option become critical American infrastructure? October 1939. Oldsmobile dealers began showing customers something genuinely unfamiliar in the new 1940 lineup. The driver moved a small selector, pressed the accelerator, and left the rest to the car. There was no clutch pedal and no need to shift through the gears by hand. General Motors called it Hydra-Matic Drive. A period Oldsmobile advertisement offered it for $57 extra and promised 4 forward speed ranges in what it described as a continuous flow of power. The sales language was ambitious, but the mechanical distinction was real. Hydra-Matic became the first mass-produced fully automatic transmission offered in a passenger car. Inside the heavy housing, a fluid coupling allowed the engine to idle while the car remained in gear. Planetary gear sets supplied 4 forward ratios. Hydraulic valves and pressure signals decided when to change those ratios according to road speed and throttle position. The driver did not have to coordinate a clutch, engine speed, and shift lever. It sounds ordinary now because Hydra-Matic helped make it ordinary. In 1940, it changed who could drive comfortably in traffic and how a large American automobile felt from behind the wheel. Cadillac adopted the system from 1941. Pontiac joined after the war. Drivers who once judged every hill and stoplight by the next manual shift could simply select drive. But the transmission's first great proving ground was not an American boulevard. Civilian automobile production stopped after the United States entered the Second World War. Cadillac turned from luxury cars to light tanks, and the army needed machines that could be driven by soldiers with different levels of experience under conditions no showroom demonstration could imitate. The M5 and later M24 light tanks used 2 Cadillac V8 engines. Each engine had its own 4-speed Hydra-Matic, with both transmissions feeding a common final drive. An official Army history identifies those vehicles as the first tanks to use automatic transmissions. That arrangement mattered for more than publicity. A tank driver already had to watch terrain, formation, visibility, and enemy fire. Removing clutch work and manual gear selection reduced one part of that workload. Hydra-Matic returned from the war with a reputation that no magazine advertisement could have manufactured. The familiar phrase battle-tested was unusually literal. Post-war buyers wanted new cars, and Detroit wanted to build them at a scale the pre-war industry had never seen. Hydra-Matic spread through General Motors, but its reach did not stop at the corporation's own badges. Independent manufacturers faced a difficult choice. Designing a reliable automatic transmission required time, tooling, testing, and money. Buying a proven unit from General Motors was faster. Hudson used Hydra-Matic, Nash used it, Kaiser used it, even Lincoln, the luxury division of Ford Motor Company, purchased the transmission from its biggest corporate rival. By the early 1950s, one General Motors component connected companies that competed fiercely for the same buyers. For the independent brands, that arrangement was rational. Automatic transmissions were moving from novelty to expectation, especially in the more expensive models where Hudson, Nash, and Kaiser needed to compete. Purchased Hydra-Matic gave them a proven 4-speed automatic without funding a clean sheet program for sales volumes far below General Motors. Lincoln gained a similar shortcut while Ford's own automatic strategy developed. General Motors benefited too. More customers meant more production volume and a wider reputation for the transmission. A Hydra-Matic badge under the hood of a rival automobile was an endorsement that advertising could not buy. The arrangement looked efficient from every direction, which is exactly why the risk was easy to ignore. That success hid an uncomfortable detail. Every one of those transmissions came from the same place. The Detroit Transmission Division plant in Livonia covered roughly 1.5 million square feet. It was modern, immense and capable of producing thousands of Hydra-Matics a day. It was also the only source. The Automatic that had begun as an Oldsmobile option was now supporting major portions of Cadillac, Oldsmobile and Pontiac production, plus several outside customers. A second plant would have looked wasteful while Livonia was running normally. Duplicate machinery, duplicate labor, and duplicate overhead are hard to defend on a balance sheet. Yet a single source creates a different kind of cost, one that remains invisible until the source disappears. On that Wednesday afternoon in August, the invisible cost arrived all at once. Construction workers were using an oxyacetylene torch near a conveyor system. Sparks ignited a pan holding a flammable rust-inhibiting liquid used on transmission parts. Plant workers attacked the fire with portable extinguishers and nearly controlled it, but the extinguishers ran empty before the hazard did. The building gave the flames almost every advantage. National Fire Protection Association material later noted that only about 1/5 of the plant had sprinkler protection. The enormous production space had no effective firewalls or internal partitions to stop horizontal spread. It lacked roof vents, and its steel roof trusses were unprotected. The factory was also about 866 feet wide. Exterior hose streams could reach only a fraction of that distance. Once the roof began to fail, firefighters could not safely enter the center of the building. Heat, smoke, burning roof material, and flammable residue turned a small maintenance accident into a plant-wide disaster. Roughly 4,200 workers were inside when the fire began. Nearly all escaped, which is extraordinary given how quickly the building was lost. But the human cost was still severe. 3 members of the plant fire brigade died after becoming trapped. A Livonia firefighter suffered a fatal heart attack, and 2 construction workers were later electrocuted during cleanup. 15 people were seriously injured. By the next morning, Livonia was a field of collapsed roof steel and ruined production equipment. Damage estimates varied, but the result did not. General Motors could not build another Hydra-Matic there. Now the transmission shortage reached the assembly lines. Cadillac had spent years selling smooth, effortless driving as part of its identity. Suddenly, its automatic transmission no longer existed in production. Oldsmobile faced the same problem. Both divisions hurriedly adapted Buick's Dynaflow, a very different torque converter automatic, to engines and chassis designed around Hydra-Matic. That was not a warehouse substitution. Dynaflow transferred power and selected ratios differently, used different controls, and created a different driving character. Engineers had to make the replacement fit, connect, cool, and operate inside cars already deep into production. Assembly plants then had to install the revised parts without turning a transmission shortage into a quality disaster. Pontiac turned to Chevrolet's 2-speed Power Glide. Lincoln switched to Ford's own automatic. Hudson, Nash, and Kaiser had to search for alternatives or wait for supply to return. Power Glide created the same kind of emergency work for Pontiac. The selector, linkages, mounts, cooling connections, drive shaft relationship, and service instructions all had to match a transmission the car had not been designed to carry. Every substituted vehicle represented engineering, purchasing, production, and dealer service decisions made under a clock that was already running. Those emergency substitutions created some of the strangest factory combinations of the 1953 model year. A Cadillac or Oldsmobile carrying Dynaflow is not merely an odd entry on a data plate. It is physical evidence of an industrial emergency. The same is true of a Pontiac fitted with Power Glide during the shortage. For collectors, that detail changes how the car should be read. A transmission that looks incorrect for the badge may be exactly correct for the week the car was built. The shortage also exposed how little the visible borders between car companies meant underneath. Lincoln competed with Cadillac, while Nash, Hudson, and Kaiser fought for buyers outside the Big Three. But their assembly schedules all depended on machinery inside one General Motors plant. The fire did not respect brand rivalry. If the overlooked engineering decisions behind American classics deserve more than a specification sheet, subscribe to Classic Cars USA. The recovery from Livonia would turn one of the most famous factories of the Second World War into a transmission plant in a matter of weeks. 8 days after the fire, General Motors reached an agreement for roughly 1.5 million square feet at Willow Run. Ford had built that enormous Michigan complex to produce B-24 Liberator bombers during the war. Kaiser Frazer occupied it after the conflict, but the independent automaker was struggling and shifting production toward Toledo. The symbolism was almost too neat. Hydra-Matic had gone from Oldsmobiles to tanks, and now its rescue would happen inside a former bomber factory. The building alone did not solve the problem. A transmission plant is a system of machine tools, gauges, fixtures, conveyors, heat treatment equipment, skilled operators, and suppliers. Much of Livonia's specialized machinery had been damaged, buried, or destroyed. Replacement equipment that normally required months had to appear in weeks. General Motors spread the work across its divisions and outside industry. An archived report from the period counted 171 machine shops in 51 American cities participating in the rehabilitation effort. Mechanics and millwrights came from around the country. Salvageable equipment left the Livonia ruins, while newly made tools flowed toward Michigan. At the older Riopelle Street facility in Detroit, workers assembled a temporary production line. 9 weeks to the day after the fire, it produced a Hydra-Matic. That pace was not a lucky shortcut. It was coordinated industrial mobilization on a scale Detroit had learned during the war. General Motors then made a remarkable choice with the first transmissions. Instead of keeping every early unit for Cadillac, Oldsmobile, and Pontiac, the company sent the initial output to outside customers, including Hudson, Kaiser, and Nash. Supporting competitors protected long-term supply relationships and kept independent assembly lines alive. Willow Run moved into Hydra-Matic production by the end of the year. Sources describe the main conversion in roughly 12 weeks, with full output restored by mid-December. A factory built to turn out Liberator bombers had become the new home of America's dominant automatic transmission. That recovery deserves admiration, but it should not erase the warning. General Motors rebuilt quickly because it had enormous financial resources, a national supplier network, and access to one of the world's largest industrial buildings. A smaller company facing the same loss might simply have disappeared. The fire also changed more than production planning. Investigators and fire protection engineers could point to a painfully clear chain of failure. A huge undivided floor, limited sprinklers, flammable process liquid, no roof vents, and unprotected steel created a building where a local fire could become total destruction before municipal crews had a realistic chance. Industrial managers across the country studied Livonia. Fire protection stopped looking like an expense that could be measured only against the likelihood of flames. It became protection for production itself. A plant without adequate separation and suppression could erase years of output in one afternoon. There is a popular legend that General Motors later abandoned the original Hydra-Matic because it was too durable and did not create enough repair business. The period record does not support that story. Warranty failures cost manufacturers money. The original design also had real weaknesses, including sensitive shift timing, heavy construction, and a fluid coupling that lacked the torque multiplication of newer converters. Automatic transmissions changed because engines, vehicle weight, fuel economy, manufacturing methods, and customer expectations changed. The later Turbo Hydra-Matic 400 used a different architecture and an aluminum case, yet earned its own reputation for strength. Engineering moved on without proving a conspiracy. The documented Hydra-Matic story is better than the myth anyway. A $57 Oldsmobile option removed the clutch pedal from everyday driving. War put paired units inside Cadillac-powered tanks. Post-war demand carried the same basic idea into luxury cars, family sedans, and rival manufacturers. Then one burning conveyor pan revealed that much of Detroit had quietly built its production schedule around a single factory. Livonia did not kill Hydra-Matic. The fire proved how essential it had become. The rare Dynaflow Cadillacs, Powerglide Pontiacs, and emergency-built Oldsmobiles from 1953 still carry that lesson in metal. Their unusual transmissions are not factory mistakes. They are snapshots of the weeks when America's largest car company improvised around a hole in its industrial heart. Willow Run restored the flow before the crisis became permanent. But the deeper legacy is wider than any one transmission. A brilliant component can become shared infrastructure and shared infrastructure can become a single point of failure. Detroit learned both truths from Hydra-Matic, one shift and one terrible afternoon at a time.